Hello everybody. Today we'll be discussing on this four important topic, that is distance, displacement, scalar quantity and vector quantity. First, the topic that we are going to discuss today is first distance. Now when we talk about in normal English or express our sense, when we say distance can be like expressing how far an object is. He is very far off from me. That means a distance we are talking about. The particular car has traveled a far off place. That means a distance is there. Or my uncle stays in another district. That is the distance. Or we can express distance in different form, or either, like for example, we say he is my distant relative. That means we are mentioning a far off or a gap in between us. So in normal English, what we speak distance is little bit different in case of terms of physics. Here when we talk about distance, distance can be defined as the actual path of movement of an object from one place, that is place of origin, to the new place where it has been. For example, if we take a point A is there. From A to B, a person has traveled 100 meters. 100 meters. This 100 meters traveling is the actual path of movement of an object. Suppose we take, for example, a person has traveled 100 meters. That means the person has traveled 100 meters from the point of origin A to the point of reaching the place, that is B. Then from point B, the person travels to point C, that is 40 meters. Now the person was traveling from A to B, that was from east to west, and now from west the person has traveled towards the north, a distance of 40 meters. If you see literally, the actual path of movement is 100 plus 40, that is the actual path covered by the person. The person moved like this 100 meters, he reached the point B. From the point B, he again traveled to the point C. So 100 plus 40 is 100 plus 40 will equal to 140 meters. That is, the person has traveled a distance of 140 meters, literally taking the path. Now this distance is from the point of origin to the point where he has reached. Now if we want to see the distance of a person from point B to C, we can find out 40 meters. From point A to B, 100 meters. So the actual distance covered by the moving object, or the actual path taken by the moving object to cover from point A to C, is called distance. Now if you take another example, suppose we take a hilltop. Suppose we are imagining a hilltop and the car has to travel in a spiral way. Now in case of spiral way, the length of the travel of the car is, suppose we take 1000 meter, but actually the height may not be 1000 meter. Actual height may not be 1000 meter, but the distance is the actual part traveled by the moving object to reach the top, that is 100 meters or 1000 meters. Here in case 100 meters, here in case 1000 meter, here in case 40 meters. So what is exactly distance? Distance can be defined as the actual path moved by a body, or the actual part covered by a moving body from the point of origin to the point where it has reached. That means it is always positive. So distance will always be positive. Distance can never be negative. Distance will be positive. Now distance is positive, plus one more thing to be understood in case of distance. Distance has only magnitude. That means the quantity, how much. If I say 1 rupees, rupees is the unit 1. If I say 5 kg, 5 is the numerical, kg is the unit, 5 is what? The magnitude. So here the magnitude is 140 meter. 140 meter has no direction. 140 meter can be east, 140 meter can be west, 140 meter can be any direction. So when I have to express anything with only magnitude or only quantity, that is called a scalar quantity. Now distance is a scalar quantity because distance doesn't have a direction. So distance is termed as a scalar quantity. In physics we have two quantities. One we call scalar quantity, another we call it vector quantity. Since we are discussing distance, distance is a scalar quantity because distance only comprises of the what we call magnitude or the quantity or the length covered by the moving object. To which direction is not important. That is the total thing. Now if we just change this one and we can think about something else. Now we have another topic, that is displacement. What is exactly displacement? Displacement is the shortest distance between the point of origin and the point the object has reached. So displacement can be defined as the shortest distance between 2 points of a moving body. That I start from point A and I reach point B. The shortest distance between point A and B can be told as what we call displacement. Displacement is not the actual path of the movement of the object. For example, if point A is here and a person is standing around here, he travels to point B, which is 150 meters. 150 meters. After traveling from point A to point B 150 meters, the person travels towards east another 40 meters to the point C 40 meters. Now from point A to B is 150 meters and from point B to C is 40 meters. If you take as a total this one, the total distance covered by the object will be 140, that is 150 plus 40 meters, 190 meters. That will be the distance. But our definition of displacement states that the shortest distance between the point of origin and the point of reaching is called displacement. So the point of origin is A and the point of reaching end point is C. So the shortest distance between point A and point B, that is from point A to point C, will be my displacement. Since it is 90 degree, I can use my Pythagoras theorem. AC square will equal to AB square plus BC square, and this will give me the resultant AC square, which will always be the shorter than 150 plus 40. It will always be less than 190. It will always be less than 190 meter. My AC square will always be less than 190 meters because according to the definition of displacement, it states that the shortest distance between 2 points is called displacement. So from A to C when I reach, I get the shortest distance between the 2 points, and that is called displacement. Now displacement can be positive, displacement can be negative, but displacement can never be displacement can be positive, displacement can be negative. In case of distance, it could have never been negative, but displacement has negative also, positive also, as well as displacement can be zero. Suppose we are imagining we have started from the point A and we reached to point B, which is 100 meters. I have traveled from point A to point B 100 meters and I again came back to point A, my 100 meters back. So in case of distance will be 100 plus 100, which is equals to 200 meters. That is in case of distance. But my displacement definitions tells me that the shortest distance between 2 points is called displacement. Now the point of origin and point of reaching is again A from where I started. So I travel 100, I came back 100. My displacement is here 0 because my starting point and end point, the shortest distance between 2 points is 0. So displacement can be 0, displacement can be positive, displacement can also be negative. We have tried with displacement positive, we have tried with displacement to be 0. We'll see one example and try to understand how displacement can be negative. Suppose we assume a person started from point A, B and he went to C. From A to B 40 meters, B to C 30 meters, and there is a point X beyond beyond A. Here what happened, the person went from A to B 40 meters, B to C 30 meters, that means 40 plus 30 distance is how much? 70. Now when he came back from C to B 30, another this side 40, so his total is how much? 70. 70 plus 70, distance should be 140 meters. His distance is 140 meters, but his displacement is 0 because he again came back to the point A. Now if he travels back from A to X, which is 20 meters, if he travels from A backwards 20 meters, then we will see his displacement will be negative 20 because it is in the negative direction. So if this was plus, if this was minus, this is negative. That means he traveled 40 plus 30, he came back 30 plus 40, displacement was 0. When he left this place and again came extreme to X, his displacement was minus 20. So distance is the actual path of movement of an object or a moving object. Displacement is the shortest distance between the two objects, or the shortest distance between the moving object of the actual path, shortest distance, not the actual path, shortest distance. Then distance is always positive, but displacement is positive, negative as well as 0. Distance can never be 0, distance can never be negative. Distance will be positive, but displacement can be negative, displacement can be positive, displacement can also be 0 because existing and endpoints will be similar. Now when we talk about displacement, displacement always has a direction. That means it went beyond positive, came back negative, east, west, north or south. So when we have a direction together with the distance, together with the magnitude, that is, suppose I say 40 kilometers towards east, 40 kilometers towards west. When I give a direction, for example, if you took the triangle, for example, if you see there was 40 and 30, suppose we assume A to B, this is C, A to B is 40, B to C is 30. Now when AC is the shortest distance between the 2 points, so AC has a direction, the shortest distance between the 2 points. Since it has direction, we call displacement to be a vector quantity. Now what is a vector quantity? A vector quantity is a quantity which requires both magnitude and direction for its complete expression, that we call it as vector quantity. Now since we have finished with what is distance and what is displacement, what is scalar and vector quantity, we can also find the difference between distance and displacement. Now when we talk about distance, distance is the actual path followed by a moving body or covered by the moving body from the point of origin to the point where it has reached. But displacement is the shortest distance between the initial and the final point of the moving body. Next is when we talk about distance can be positive. Distance can only be positive, but displacement can be positive, negative as well as 0. That is in case of displacement. Distance is a scalar quantity and displacement is a vector quantity. So these three we can easily remember, then one or two we can just add it up if we think required. Like for example, distance will always depend upon the actual path of the movement. Distance will depend upon the actual path of movement of the moving body, but displacement will depend upon its initial and final point. It has nothing to do with the actual path of the movement of the moving body. Then we can understand that distance is a scalar quantity and displacement is a vector quantity. So if we sum up this entire thing or summarize whatever we have done, we can start with distance is the actual part of the movement of an object. Displacement is the shortest distance between initial and what we call about the final position of a body, irrespective of the actual path movement in case of displacement. Secondly, distance is a scalar quantity, displacement is a vector quantity. Distance can only be positive, displacement can be positive, negative as well as zero. So these things if we can remember, then our entire part of distance and displacement concept will be clear.